YouTube, hello, welcome on into Pong for the N64 development. I'm not sure how many streams it's going to take to kind of complete this list, but at least I want to get to here on line 16. So these first 15 items. Our current to-do list, we will be doing these in order, just kind of, it builds up. So we don't have to do something completely complicated and refactor it, blah, blah, blah. We will be doing some changes up as we add stuff, but we don't have to do everything all at once and have so many bugs. So the first one we're going to do is initialize everything and just make it print hello world to the center of the screen. Just very standard to make sure everything's compiling and working right the way it should. Next we'll be drawing the graphics, which will be the player paddle on the left, the CPU paddle on the right, ball in the middle. And then I'll adjust them to be in the middle of the screen. I just put them at like 2020 on each side, just to be safe. And then we'll set up so the score counters are on the top portion of the screen. We may set them to a different color or transparency just so things aren't overlapping and looking cluttered. Then we'll set up a screen, the first scene to be press start to play. So everything will be here. What we should expect when we start the game is we'll see the paddles and then 0 scores on top, and then in the middle it says press start to play, or somewhere on the screen. Then after that, whenever we press start, we'll set it up so the ball begins to move on its own, and then have that movement logic set up. At first, it's just going to start pointing the same direction at the same speed every time. Once we get down here on line 16, where we'll start with random velocity and direction, that's when it's going to kind of mix it up, but for now it's just going to be same old, same old. We may change its direction. Whenever we want to test a player collision, it'll go towards the player, but when we test the CPU collision, it'll go towards the CPU, and then we'll change it. So after we get the ball able to move, we'll begin to move the player, so we'll get the input for that off the controller. And I'm using a, I don't know what they're called, they're the Xbox controllers that came with my Series X. I think this one I bought as an additional one, but you know, it's the Series X controllers. We're working with Ares emulator, so whenever we get to there, we'll show that off. But I got it working yesterday, it's all set up, so we shouldn't have too many issues. And once the player's able to move the way we want it to, we'll set up the collision for the ball and the player. So once the ball hits the player's paddle, it bounces back in the opposite direction. I'm not sure if at this point, if we want to do it just goes the opposite direction, or if you kind of want to change up the angle. We may set up a random angle for it to go by changing the Y velocity. But we'll get there when we get there. And then once the player paddle ball collision works, we'll set the logic for the CPU to move, and then the ball and CPU collision logic to work. Kind of same thing for player, but just on the other side. And then we'll set up the ball's top and bottom of the screen collision, so instead of just flying off screen, it bounces. Then we'll set up a pause screen. Whenever the player presses start, or whatever button we designate, it'll stop everything, set up a pause screen, press the button to resume. We'll set up a simple, the game's over when we reach a certain score. We'll probably do, maybe 5. We'll maybe do 1 or 2 to test it with, and then change it if we want to. The next task will be whenever we reach this game over screen, press start, and it restarts, 0-0, ball, begin. Then we add the ball starting with random velocity and direction. That one, I just realized is going to need checks to make sure it doesn't go straight up or down. But I think if we, that'd be easy to make sure it doesn't start at 0. We'll do random number generation. Anyways. And then, once we have all of this, technically that is working Pong. We'll start to add some more stuff to it. Instead of just playing start to begin the game, it'll go to another screen where we can, we'll have options. We can either set the score, the target score to reach, or a certain game mode. So you can say like, first to 5, first to 10, or if we want to do any other thing that would be kind of interesting, be like high speed or smaller paddle, stuff like that. Next up will be velocity momentum. So instead of everything moving at its top speed instantly, it ramps up. Not a huge, not a game-changing factor, but it's going to be a little extra logic to add to it, just something to do. And then the next one I could think of would be the ball changes color. Either during gameplay, it shifts, it does a hue shift, or whenever it hit by a paddle. We can also do if it hits by a paddle or if it hits by a screen, top or bottom of the screen, it changes color like the the DVD player screensaver. That should be good. So first up, we do need to set up our makefile, which we're just going to make a basic copy of the example ones. We don't have that big of a project, so we don't need to include a whole lot. We'll do N64 Pong. .z64 is the file type of the ROM. The phony. The Dragon Dash preview. So for the RDPQ functionality, there is some in the stable trunk branch, but we will have to be using the preview to do everything else that we want to do. As they have not moved it over yet. Oops. And we include for installations. Include their N64.makefile. Our objects. Oops. Build directory N64 Pong.object file. N64 Pong. C64. And we set the ROM title. N64 Pong. This is not the most interesting, I do apologize. The elf file. So objects. F. C64. Oops. Colon. Clean. And then include wildcard. Build directory. D. Oh no. So here I have a folder called file system. That's if we wanted to use the DFS file system. But as we don't actually have that, we're not using the file system, so we don't even have to initialize it. But as if we had things we need to load or need to use. And I need... So that should be good on... It would be if I had hit the right button. And the only reason I'm calling make right now is so that as I start to type, it'll know where things are. It may be able to do that without calling make, but I have not had the best of luck. Like this. Why do we not see LibDragon? Oh, because I have a different file name, that's right. Let's do... Fine, we'll rename this. Do I have them as underscores? No. Dragon preview, that's right. If need be, I do have another project that I was working on last night that has this. I'll just check its make file. I'm willing to bet I just did not include the right thing. Include n64.make. I'm just gonna rename it to everything to Pong, so I don't have everything in a different way. Rename you just Pong.c. Let's open. Okay, so that was because this extension's kind of dog shit. Lovely. I think all we're going to need is going to be libdragon.h. I'm trying to think if there's any other things we need to define. We could define a few colors. Oh, but let's remember how they define RGBA 32. Oh, fuck. That's fine. We'll just punch the colors in by hand. That's not something we need to worry about. Let's do display. Initialize our display for resolution. Read 2240. A depth of 16-bit per pixel. Let's give it 3 buffers. Don't correct gamma. And set filters to resample. We'll do the stuff for our display here. So we'll set uint32t display width to display get width, just so we don't have to call the longer function each time. Excuse me, had to cough. Let's initialize joypad. Our timer, which we'll need whenever we do delta T. Our DPQ init. I do apologize, I have a very click-clacky keyboard. So if you do hear that and that's annoying you, I'm so sorry. Next, we're going to initialize some fonts. Actually, let's move. That's technically a display thing. Let's call up our DQ. We'll create font 1 in case we make others, but I don't have any font files to use. We could pull ones from system. Why do you not have... Uh-oh. You should be pointing to the right version of you. Preview branch, correct. Make file. This is right. Inst. The Dragon Preview? The Dragon Preview, because we have the rest of it. Oh. I forgot Phony All. This is on the wrong side. Okay. So that's just gonna give me errors because I'm still working. But now we should have, yep, there we go. Helps when you type things out correctly. This font 1. Again, just in case we get more fonts. Fonts load. Built-in. Fonts, built-in debug mono space fonts, DQ, text, register that font. We'll give that ID 1. 0 is reserved by system, so if you try to use 0 anywhere, it will throw an error. Q. We create the font style for this using font 1, which has the ID 1, and we have to DQ fonts style T. I'm going to give this one color GBA 255, 255, 255, 255, which is a white. Fully visible. Yeah, white and fully visible outline. No. Right? These ones will give zeros. That should be pure black visible. Unless it's backwards for some reason. And in case I want to add more to that, I'll leave that like that for now. So the first thing we're going to do is just print hello world. Let's file 1, so our infinite loop. Let's do... First we need to prep the screen, so surface P, let's display. Oops. Let's display. Try get. We'll attach TPQ. Attach clear. Display. Surface null. We are not doing anything 3D, so we don't have to worry about that. Now let's give it a black background, DPQ, set mode, set mode, fill, GBA, 52, OXOO, 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 0. Our DPQ, so rectangle at x0, all right, yeah, at 0, 0, out to the display width by the display height. Then I have it written down. Where's the create font for the text print F? Sorry, give me a second. I'm checking notes. Here we are. Just because there's a lot to this. DPQ, text, printf. We are not passing any parameters. We'll have this using font 1 at x. Let's say x 100. Display height by 2. I think that's going to try and center it. It's going to close to center it. And then to print this, we need to call our DB detach shell. Got a few issues. RGBA 16. I used 32 earlier, that should be 16. We'll set that to be zeros. And then over here, this should be we have one there. These, that brace, that goes there. Those two are closed. These braces are on the initializer. That should be 16, that should be 32. I was right the first time. I think I actually need to change. Let's change from 16 BPP to 32. Clear that. Outline color. Still forgot to change that. Which did fix it. Okay. So let's pull up Aries. Pull up our Z64. You guys should be able to see that. There it is. And it says hello world. It's not completely centered, but that's close enough. That show unloaded? No. But that is first task done. Next, we need to draw our graphics. So we can just go ahead and clear out this one. So that creates our black background, gets the screen. So next we will need to set up our entities. I don't know the best way to do this. So someone's gonna see the way I do it and be like, oh, that's disgusting. I know. Right now we're not working for, well, no, it's not gonna be optimized. It's not gonna look proper. You have to give it X position, int Y position, int width, int height. And that's the only things we're gonna give it right now. Let's do struct entity player. X position, we'll do 20. Y position is 20. Then width, set to 10. Oh, these should be on this. And height we'll set to 100. No, 50. Let's do 50. Just remember how big the screens are. Struct entity, called one for CPU. Its X position will be set to display width minus 20. Let's do minus 40, because that's gonna count for our actual width. It's 20. Our width will set to 10. So then that should be 30. So they're kind of matching. Height is 50. Struct entity. We'll create one for the ball. X position. It's gonna be capitalized. Let's do display width divided by 2 minus 5, because this is gonna be a 10 by Y position. Let's do display height divided by 2. Again, minus 5 because we're a 10 by. Width equals 10. And height set to 10. DPQ fill. Rectangle, if I can spell, at player.x position, player.y position, player x position, plus their height. Y position, no, x is width. I was making that mistake last night too. Dot height. DPQ CPU X position, CPU dot Y position, and CPU dot X position plus CPU's width, and CPU dot Y position plus CPU dot height. DPQ. Rectangle adds ball dot X position, ball dot Y position, ball dot X position plus ball dot height, and ball dot Y position plus ball dot height. So these positions plus height or width. Should be width. No, that should be height. This should be width. We could put these on a separate thing in the struct to automatically calculate these other end. Yeah, we could combine these to x1 and x2 by 1 by 2. But for the moment, I just want to get things drawn. So we have problems there, that, and that. And we make, I open Ares. Ares is visible. And show me paddles. Uh-oh. GPQ set to mode. Fill. RGBA 32. OXFF. Oops. OXFF. 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 No, we'll just 0. Make there we go. It was right, but it was printing them as black. Unload. Hide that. Cool. We are kind of chugging along. Let's do this to. Let's give it. I don't want to call them X1 or X2, but X1 position, Y1 position, int X2 position, and int Y2 position. These will be auto-calculated, but I'm just gonna X2 position. We'll set them to 0, and then immediately calculate them. I would do it here, but it kind of gets angry at me. And then dot Y2 position. I do apologize. I actually need to use a brush trim. I'm so sorry. If you want to give me 1 moment. Alright, thanks for waiting. I do appreciate you. So now we have all those positions changed. What problems do I have? Entity has no field X position. These. Okay. It's 1 position. 1 position. It's 2 position. 2 position. 1, 2, 2, 1, 1, 2, 2. So we don't over-calculate that. I'm sure there's a faster way of doing that. I just didn't know it. It's cleared out. Let's make this. We should not have a difference. That's kind of the idea, is that there should not be anything different. Except I did not calculate. Plates. T and E positions. Player.x2 position set to player x position x1 position plus player dot width player dot 2 position player dot y1 position plus player dot height. Yeah, CPU dot x1 position plus CPU dot width CPU dot y2 position one position plus Q dot height. This is slightly overkill for this moment. I don't want to have to retype all of this later. So doing this now is gonna save me some effort. This one position plus ball dot width ball dot 2 position equals ball dot y1 plus position plus ball dot height. Cool, just as we had it. So for the first Y position, it needs to be set to display. Height, divided by 2, minus... I'm just gonna hard code it. It's our dot height, but half. Don't like hard coding numbers, but fresh value straight from my ass, but I know where it's from. Nice. So that was title starting in the middle of the screen, height-wise. Drawing our score. DPQ, set mode fill. Let's pick OXFF, OXFF, OXFF. What is half? X2 decimal. It's OXFF. 25. Half that's gonna be 127. OX7F, we may change that. DPQ. These now need dots, these need scores. Is that right? I know this is working, but isn't this supposed to be no. We're initializing that's right. Score is 0. Score equals 0. And though the ball isn't supposed to, I'm gonna assign it just in case. Either throws an arrow or something funky kind of happens. HTTP A2. Next, print F. Don't have any parameters. On ID, we're using 1. And X, say 10. I'm gonna do this. Let's just say 50 for this one. And this one is percent. Nope. D. Where? Score. Same thing, except now it's CPU score. Instead of this 50, it's going to be display width minus 50. That's not going to be perfectly centered because of the, or not exactly mirrored. It's going to be off because of that. Off because of the 0. I'm not counting for the space it takes. I'm trying to subtract. I'm not subtracting how long that's, or how big the string actually is. EF. We may just stick with white, or I can generate like red if we have to. PQ. Text, it's F. No parameters. Using font ID 1 at 10, 50. Say 5. Let's call it 100. Make chat. I keep getting X and Y backwards. That's the issue. I'm getting X and Y backwards, and I don't know why I'm doing that. I swear I know my directions. I know how to graph things. Not dumb, I swear. Not perfect, but it works. Now let's see about X7F. If we have to, we can just leave that like that. That's... Just try pure red. If I don't have these numbers backwards. It's completely possible that I do. Or just nothing happens. Sick. Oh. I know I'm doing wrong. I know what I'm doing wrong. I'm gonna assign these to 2. and where we did our fonts, DPQ, font, style, font 1, we're gonna assign it to 2. Let's create a new font. DPQ, font, style, T. Color, we'll use RGBA 32. 5, 0. I mean, we don't need to. Oh, 1 second. Alright, sorry about that. I figure dinner. Someone had a question. Color. Equals RGBA 32. 0, 0, oops. Okay. 2, 0, 0, 0, 5. If this gives me a blue-green mixture, then it's backwards the way I'm think it's supposed to be. Hit. Let's do DQ text, register font 2, font 1. Do need to quit closing areas every time. What do you mean? And then does Q text F using font ID 2, that should be correct. I'm just gonna redo this, except for, oops, the second one was called font 2. I'm not sure why that's not going to just be a different color. I misspelled make. It's bullying me. What is the way our GBA32 is? GBA2 or RGBA32. I don't know if I'm saying that wrong. Creates color T from the color components RGBA32 range 0 to 255. Here should be all black. 255s should be white. White with a black outline. Red with a red outline. Wonder fault, the debug mono just can't be colored. DPQ, wonder next, register font, the font ID of 2, using font 2. Using font 1, registered of 1. White with a black border. Font 2 using 2. Creates red using red outline. to this location. There's something which is off. Trying to load already loaded font data. Okay. So I can't. Don't need to do that. If it doesn't change color. Okay, I've grown tired of trying to figure that out. There's no reason to anymore. Screw it. So we can print scores. That's a good enough location for now. It's not anything wrong. Now we need to set up scenes. Scene. To start scene. Game start. In game. We're eventually going to need pause. Game over. Hi, cat. We'll call it mode set for whenever we get it to, so we can set a number of stuff later on, just to have that there. Oh, hush, cat. That's being annoying. Score. From here we'll... Nope. Enum scene. Scene. And we'll set this to start scene. Switch current scene. EQ text F null 1 at 50, 100. Press start to play, exclamation points. And we'll just break for now. All I want is just to show that that scene's going to load as the way I want it to. Good enough. Oh, I just realized Ares hasn't been showing for you guys. What the fuck? Hi, cat. Why's Ares not showing? What the fuck? There it is. It takes forever. This takes forever. We don't read controllers yet, but if we have the scores, they've been, I don't know how much, I just realized I haven't been looking over, so I don't know how much it's been showing. But these have not been changing color, but that's good enough location. Player, CPU, ball, press start to play, score. You need to quit yelling at me, cat. I'm not giving you attention. Or don't want you on my lap right now. So now, we need to read our controller. Should we do with... Whole joypad inputs T. I'm just calling it controller. Joypad gets inputs. Joypad port 1. Helps if I spell things correctly. But this function in particular, I think we're going to need to change. So I want to... I mean, this will work for now, but it's going to count every time a button is pressed as held. So if you're holding down a button, it won't count it once. It's going to keep counting it every frame. Which, you know, if that's how you want it to be, that's fine, but... Oh, excuse me. We may have to switch this between 2 holdings, so this will, our button as buttons underscore pressed, because I don't want them to be held. And you are a joypad buttons T. And then we'll have a second one, joypad. Do we want... joypad 8-way T? And that's going to be controller stick. Capitalize this for camel case. That's going to be under joypad. Get direction on joypad port 1. And as we want the 2D stick, we want joypad. Nope, where am I typing? Joypad 2D stick. That should be our analog stick. So that way we're not playing with the D-pad, where you're playing with the analog stick. But we could, whenever we do check input, we could set it to be either with the controller stick or the D-pad. That may cause a little bit of an issue, depending on if you're holding both of them like an asshole. And let's check for if controller button dot start. We're going to set current scene to start. So as we have it, once we enter in the game, it gets the thing, sets the background, or yes, it sets up the display, attaches to it so we can, clears it so we can draw into it, creates a back, makes a black square or rectangle that is set at 0, 0 to display width, display height, so there's a black background. We calculate our entity positions, our player. This is just going to make typing out the collision a bit easier for me to think about. And then we draw our entities using using white for the rectangle for the player, the CPU, and the ball. We draw out the scores. Here we read the joypads. We have one set up for the buttons on the joypad, and then here's one for the controller, the analog stick. So we get its direction and how much. So we're getting that analog value on joypad port 1, so these are for both the first controller. The reason we had to set up is that we could have done it with joypad int T for a controller, joypad get inputs on port 1, but that gets us every time a button is pressed or held, it continues to count it. This one here, we only get it if it's pressed, not if it's held. So we get the first initial one, and then it waits till it's released and then pressed again. That should be the way it does it. And then, because current scene is defaulted to our start scene, we load up our start scene, which prints press start to play on the screen. So the screen should have our characters, or we'll call them entities, the player, the CPU, and the ball, and the score, and then the press start to play. We press start, and then that's going to change the current scene to game start, which in case game start, you're going to give ball.x. Oh, we have to assign create velocities. Let's put that there for now. And break, so I have to type that out later. Entities will now have int x velocity and int y velocity, which is just going to be, for now, speed of the x and y directions. Int x velocity. We'll set these to 5 for now, so these will be our top speeds, which this is what they'll move at whenever they are called to move. We'll be adjusting that towards the end. That's kind of the last thing we have is the velocity momentum ramps, which we can tighten up to be, do we want it slippery or do we want it real tight? Which, doing it this way is classic Pong, so not a huge deal. Ooh. Actually, so this way we can, every time we restart the game, we change up, we can reassign the velocity. So it just doesn't continue the same way as when the game last ended. And then we move this to scene, we set to in-game. And here's where we'll set up the position change logic. But for the moment, we're just going to set break. Excuse me. Yes, we do not call controller stick yet, so that's what that error is. It's like, hey, you've set this up, but you're not calling it yet. Now on this controller, let me turn it back on. I press start. Nothing happens because we don't have any movement set up, but pressing start, the text went away. We are currently in game. We press start, went to game start, we assign the velocity, moved to in-game, we're now in-game. Yeah, shit on my desk. Oh, and I don't think I showed that. F. I'm not good at this, I swear. Alright, so we have start to play, I press start, that text goes away, that tells me we're in-game, as things have updated. So it's going the way I wanted to. So for in-game, the order I want to do this is update player, then we update CPU, then we update ball, and we're gonna do the ball first because it's going to need both left and right and up and down, so it does have the other axes we have to worry about. So first we move ball up, then if we have to, we'll move ball down, move ball left, move ball right. We could break this up into horizontal and vertical. Which we will do. That shouldn't be too bad. So we'll make sure the ball.x velocity, if we are greater than 0, that's going to move us to the right. The top corner is always 0, 0. And I want bottom corner to be 0, 0, but that's not something we're going to be able to get, sadly. So let's do a new position. Set that equal to ball.x1 position. And we'll add ball.x velocity to it. If new position is less than or equal to 0. So that's going to check if we are on let's for the other side. Oopsies. If the new position is greater than or equal to ball.x2 position. Ooh, that's making that real nice. We don't have to type out that math. ball.x is x1 position. We'll just say is we don't actually have to change that. Ball.x1 position. Just so there's no change, else if new sorry, give me a second. Or less than ball.x2 position, ball.x1 position is equal to new position. We don't actually need this one because we're not doing anything, but I like having that explicit here's what we're here's the plan kind of thing. Else if ball.x velocity is greater than 0 or is less than 0, excuse me, move left. Into new position equals ball.x1 position plus equals ball.x velocity, which we can do. We don't have to subtract it, even though we are moving to the opposite direction, because if it's a negative, if we add a negative, it will still be subtracting. So we don't have to worry about making sure all of our signs are the correct direction. And this one, you know, let's try it without that. The new position is less than or equal to 0. The position is greater than 0. This is not right. That is not the way I want it. Position is greater than display width minus ball.x2 position. Greater than 0. Then we set ball.x1 position to new position. Otherwise, nothing changes. Actually, let's do this. If the new position is greater than or equal to display width minus that, then we set hold. I have to draw this one out. Hold on. Fucking numbers and logic is getting to my head. I've done this. So we have full display width because we're doing this from x1 position. don't think I'm saving that much more space on this. Let's just try that. I think that's right. And then here, else if the new position is less than or equal to 0, ball.x1 position is 0. And if the ball's velocity is 0, it doesn't move, so we don't need to do anything for that. I'm going to steal this and change it to move down and up. And the reason for that is down is positive, up is negative. So we can kind of keep these the same. Oh no, I win. Height, or display height, y2 position, ball height, of the y1 position, height, the y2 position, and just change these up. Y, y1, and then y1. If the velocity is greater than 0, it heads down. So the new position is equal to ball's y1 position plus the y velocity. Because it's from this first corner, the top left is what we were counting these from. The new position is greater than or equal to the display height minus the ball's y2 position, which should give us that offset. The y1 position is set to that spot, so it should... It's gonna stop, but we do actually need to change that. So that way we can do ball dot y velocity is equal to negative ball y velocity. And then we change this one as well to ball.y velocity instead of equal to negative ball y velocity. So it maintains the same velocity, but just changes direction. Get a colon there, or semicolon. I think that's right. So first test, it's gonna shoot to the either left or right, and then it's gonna stop when it hits that side. Then I'll change direction to make sure it goes on the other side, and then we'll move it up. And then if it bounces up and down, then that's fine. We don't have to move it down. Oh, it's freaking the hell out. Neat. Should I be shooting it? Y velocity should be y. X velocity is 5, so it should be moving left, right? Position. At the... I think that's incorrect. I may have been adding that by mistake. Or we don't need those. So let's see if recreate that. Oh, again, sorry, I wasn't showing it, but it wasn't right. Start. Same behavior, but that looks cool. Let's see. How did I do this before? I may just split this up into left and right. So we move up. So from here, we move right. If we are greater than 0. The new position is the x1 position plus the velocity. If and then we'll change this to width. I think I'm just miscalculating it. Yeah, I am. That sucks. So the heights. That's the heights. This should go kind of up and over. No, it'll go to this corner. Or not. That's better. So we're not moving up and down correctly now. So when moving right, display width minus ball width. The X position is set to display width minus the ball width. The new position, set U to that. Display width minus ball width is the new position. Moving right, for moving left. If the new position is equal to ball left, greater than or equal to 0, the new position is 0. If we are less than, assign the new position. When moving down, calculate the new position. If the new position is greater than or equal to the height minus ball height, y1 position becomes the new position. No. That should be right. So that way, it sets it to the bottom of the screen, changes the X velocity negative, so it goes the other direction. And moving up. Which will have the velocity as negative. Calculate the new position. The new position is less than 0. No. No. Greater than 0, the new position, the ball position's the new position. If it's 0, we set it to 0, and we change the velocity. I don't remember what I changed. What did I change? For the moment, let's just set it to 5 and -5 respectively, just to get it going. Let's clean and try and make again. Come on, Ares. I don't want to capture this display if I don't have to. There we go. The ball does not move the way I want it to. Greater than 5. We add the velocity, so ball Y1 position should be added. A lot of if statements. This looks gross. Yeah, I should work on verticality. That does that, then goes down to here. If you know what? This is gonna be weird. I'm just gonna break these elves. Not the best, but it works. I mean, if it does work, then it's gonna be a why does this work type thing. And it doesn't. Okay. It's the exact same thing I had last night and it worked. I'm just going to break these. I think let's not calculate those. I think that's what's fucking me up. So we're gonna change this. Getting rid of these. I think trying to think of it in that way it's what's really screwing me up. So get rid of those. Player dot x1 or x position plus player dot width. Comma player dot x position plus player dot height. So this should be y. I get into a routine. That's what really messes me up. CPU dot x position plus CPU dot width by CPU dot y position plus CPU height. Then ball dot x position plus ball dot width, ball dot y position plus ball dot height. So now we update the ball. Move ball up. If ball.y velocity, we're just gonna try up. We're gonna do these one at a time. And then int new position. It's ball.y position. Adding ball.y velocity. We don't need an equal sign there. If new position is less than 0, ball.y position is 0, and ball.y velocity is +5, so it moves downward. Else ball.y position equals new position. Else if ball.y velocity is less than 0, int new position was ball.y position plus ball.y velocity. If new position is greater than or equal to the display height minus the height of our ball. Ball's Y position set to the new position. No. No, that should be display height minus ball's height. And then ball.y velocity, we set to -5. I have too many things. Else if new position is less than display height minus ball.height. Ball.y but bally.y position equals new position. Ball vertically. Let's just run this. So I don't mind those errors because they're just going to be there until I add the controller scheme for the player. This should move us up and then down. Cool. Now let's do move all horizontally. If ball.x velocity we have it as greater than 0, which moves us to the right. Into new position equals ball.x position plus ball.x velocity. I know we could only calculate that once every time by having a new x position, new y position, and then just we'll clean up once we do this. I just want to make sure this works before we try fixing that new position. Less than or equal to 0. It's going to set ball.x position to 0. Else if new position greater than 0, ball.x position is new position. Easy. we don't have the score counter yet, which we'll be adding to these, like how these have it balanced. The horizontally will check for scoring. X velocity less than 0, so this will move us to the left into new position plus ball.x position plus ball.x velocity. If the new position is new position is greater than display width minus the ball width. Right. I think so, because that's gonna count for let me set that to ball.x position display width minus ball width. Else if the new position is greater or less than or equal to display width minus width of the ball, and the ball's new x position is equal to the new position. Let's make, and it should fly off to the corner after I press start. And it does. And it bounced. Lovely. But that one did not count right. Okay. So the new position is greater than the display width minus the ball width. I should have set that. If the new position let's try that one. I wonder if it just didn't catch properly. I'm waiting for Aries. There we are. Nope. All right. Then let's do this as, because this is going to be all the y velocity. No, let me do it. X velocity to 0. I'm gonna do the same thing here. All dot x velocity to 0. Just so it should stop dead right in that location. And that's what I'm looking for, is that it recognizes its location and then stops. I'm gonna wait for Aries. Why is that not doing that? Greater than 0, meaning it's moving to the right. We calculate the new position. I think I have this backwards, don't I? Yes, I do have these backwards. These signs should match. I think that's what I did wrong. I had signs backwards. Oopsies. And wait for Ares to load up. I don't know why Ares takes forever to show up on OBS. There it is. Okay. So it does that. We can put these back to where they were. Actually, I'll leave them down, because we will have to recount that. Even we could, if it's... Nope. CPU... Dot... CPU dot score. And on this one, we add 1 to player dot score. And then current scene equals game start. And then current scene equals game start. So the reason I'm redoing why this works is that when it reaches the left-hand side, the CPU gets 1 point. When it reaches the right-hand side, the player gets 1 point. And then it resets the game, or the scene, to game start, which here it's going to, once we get it to randomize the X and Y velocities so it doesn't shoot off in the same direction every time, it just resets where the ball is and then starts puts it back into here. So that is ball moving. Not bad, but let's test that score. And when we watch it, it should... we actually have to change ball.x position and ball.y position. So that way it recenters it. Wait for Ares to show up on stream. Actually, you know what? Give me 1 second. Let's find that. Okay, cool. This works. This will be better. Sooner we press start, the ball should go to the right, count 1 on me, and reset. And it does. Nice. Exactly that's what we wanted. Now we need to change these. So now it's going to start going towards the player, and we're going to update the player. We are not checking for collision just yet. So here, if controller stick is greater than 0, I should be moving this up. Yes. Into new position, equals player dot y position minus player dot y velocity, just because we don't have it automatically changing our velocity depending on which way the stick's going. That's a near the end kind of thing. We are at 0. Player.y position to be 0. Else if new position is less than 0. Player.y position is the new position. Then else if controller stick is less than 0. We recalculate into new position, same as always, except this time we are adding player.velocity. If the new position is greater than or equal to display height minus player's height, then the player's y position is that display height minus the player's height. Else, if the new position, hit too many buttons, it's less than that display height minus the player's height. Player's new y position is that new position. And that's all we need because we are only moving on that one axis. Let's bring back Aries. Excuse me. Oh, it's not going to show me what it's registering as. I think we have to I think it's just the way I'm working on the joystick. I think I have this wrong. So I'm using an 8-way T. This should be as get direction 8-way T. Returns the enumeration value of the 8-way T. Controller stick dot joypad 8-way up. Is that what that one was? Up, and then this joypad 8-way down. C6 around assignment use as truth value. Oh, Duh. Oopsies. I'm doing logic, not assignment. Pull up Pong. Yep, there we go. I wasn't counting it right. So now we move our player. Good. Let's set up the collision for our ball and player. Excuse me. Ball collisions. Ball to player. These are just gonna be a few simple bits of logic here. Ball.x position. Player.x position plus player dot width. And the ball y position is within player.y position, and the ball's y position still within player.y position plus player.height. That's going to give us set ball dot velocity, x velocity. Let's try straight up multiplying it by -1. And then ball.y velocity. Let's give it a random value between 5 and -5. It's 5. It's 5. It's a fucking weird ass formula, I do apologize. But that should give us times -1. Hopefully I can do that inverse multiplication with no problem. So whenever we hit it, it should bounce off at the same speed on the X, but on a different Y. Ooh, it can get stuck. Yeah, that's pretty, that's cool. Oh, I like that. That's cool. Get excited. Alright, so with the player and ball collision, let us move our CPU now. Which will be, again, easy. All we have to do is have it check where the ball is compared to the Y position. A lot of if statements. So if the ball's Y position is greater than or equal to the CPU's Y position, then have a new position, CPU dot Y position minus CPU dot Y velocity. If the new position greater than or equal to, or yeah, just greater than 0. CPU dot Y position is 0. Else if new position greater than 0. Don't have it if it is 0. Do that here. And CPU dot Y position is the new position. So this one is I think I could do a different setup here. So we have if the ball's Y position, and hold on, we are moving up. So this one is if it's going to be, yes, if the ball's Y position plus the height is above the Y position, or if the ball's .Y position is greater than the CPU's Y position plus its height, then it moves. Else, if balls... No, I think that's not right. I only need one of these. That's right. That is correct. I'm trying to do multiple things at once. But counting if it's above it too. That's not right. If the ball's Y position and its height is greater than I'll get this here in a second. So this would be the bottom of the ball. If the bottom of the ball is less than or equal to the top of the CPU, then the CPU is going to move upwards. But if it's at the top, then it's going to stay at the top. But if it's not at the top, it's going to move up. Else, if the ball's Y position, I don't need this to be on two lines. I'm only checking the one side. Y position is greater than or equal to the CPU's Y position at the bottom, then its new position is CPU.Y position plus CPU.Y velocity. If the new position is greater than the display height minus the height of the CPU, then CPU Y position is set to the display height minus the height of the CPU what character. Else, if the new position is less than display height minus the height of the CPU, then the CPU's Y position is the new position. Ah. Ooh, we dropped some frames a little bit ago, but we seem to have recovered. We'll make bring up areas again. Could give it a small buffer to have it work a little bit, to have it move a bit faster. Because right now it's like checking it pixel perfect, but we could also have it move faster. I'm sorry, I got distracted. I'm having fun playing half-ass Pong. It's actually a ton of fun. I love simple shit like this. Ooh. Change up the tunes. Let's give it the... Let's give it a buffer of 2 pixels. So this way it should react a little bit faster. Yeah, you notice there's times where it's going to get stuck either in my paddle or behind my paddle because I don't have the... It should have gold. Yeah, it should have gold for the side, so there's just something up with that. And this is unfair because the CPU can't bounce it back. So let's give it... So that's moving the CPU. The CPU can officially move now. So we'll set up its collision. Move the ball horizontally. And then ball to CPU collision. So this is almost the same, but there is a slight difference because we are having to calculate the other side of the ball to the other side of the CPU as we are from the player. So we check the width side of the player, but now we have to check the normal regular side of the other side of the CPU one. So we don't count its width. We are only going to count the width of the ball. So for like this first one here, ball dot X position, we have to include the ball dot height. And I'll just give that its own parentheses, and that's going to be if that's greater than the CPU's dot X position and the ball's Y position is greater than the CPU's Y position, greater than or equal to. So if that's if it's on top, if the top of the ball we'll adjust that so it can hit one corner. I think I have an idea on that one. And then if ball's Y position is less than or equal to the CPU's Y position plus the height of the CPU, then ball dot X velocity equals -1. Ball dot Y velocity. We do the rand function again, so I'll just copy that. So I think this one here, we can change to the ball's Y position plus, that should be width, not height. Plus the height of the ball. Give it the buffer of 2. And then this one here again. Let's give it that buffer of... I think let's do +2 for this one. Hold on. I'm sorry. If I go silent, it means I'm thinking about it. Position +2 would be here. To that. Okay. That looks like that's the way I want it. Bounce. I wonder if... that seemed to work. Okay, I just think I have the directions for the CPU moving, so we'll double check that real fast. So moving the CPU. If the... bottom of the ball... +2. Top ball. The CPU +2. Note that needs to be -2. Let's try this. Ooh, got stuck. That was my fault. Okay, so now we have the issue of point detection. Let's try commenting out this position. So it doesn't send it backwards. Ooh. Sorry, I had to check a Discord notification. I mean, I don't have to do any fucking DMs or anything. Stop yelling at me, cat. Oh, that was live. Okay. I mean, that wasn't anything bad. I didn't need to do that. Yeah, we need to check this. Berries, Pong. It still gets a little stuck, but... Oh, it got me. Okay, so we need to set up a 10 pixel barrier on the top and the bottom. For the player and the CPU. Let's do 12. So the the ball can still sneak through. If that does happen. We'll adjust this value. And this is so when I do change it, I can change it all for once and I don't have to change all of it all the time. So we do need another one of these. Minus greenbound buffer. That should stop us at that 12. Oops. Want to copy, not paste. Change that to the screen bound buffer. I probably need to adjust the signs on those. Nope. Hold on. Nope, that one needs to stay. This one gets the greenbound buffer. We have a few issues. Needs that. That needs that. Get my fucking ass handed to me. You can see the tearing on it, or the ghosting, because it's not set up with Delta T just yet. Or no. So things don't move perfectly smooth the entire time. Okay. Let's do... kind of like that better. We already get the ball top and bottom collision. Let's do a pause screen. So now we need our pause scene. all that first. Then paused. If what I call it controller button dot start current scene equals pause, and then immediately breaks. So now we go to our next case for pause. That's what we say if controller button dot start current scene equals in game break. So I'm hoping that it's not going to just, if you press it, it's not going to keep spamming it. Because it should not pause after I press start. Ooh, yep, that's the way I want it to work. Cool. And then when we are paused, we say RGBQ text printf using 1, or no, null at 1, or font ID 1 at 50, 100, nope, 100 paused. And make, excuse me. Let's do 100, 100? That's not gonna be center because this is a 16 by 9, or no, 4 by 3. $150. There is a way to set it up so that font should be centered, but I think it's for a different print function. And that's fine, like this works. It doesn't need to be perfect. There's no issue with the collision as it does this. Actually, you know what? We can make our score collision a bit easier. Make clean and clear, so I don't want that piling up. Where is our score? If the new position is player dot, yeah, player dot X position, and then on this one, if it's greater than CPU dot X position plus CPU's width. So that should tell us if it's on the other side of the screen, or on the other side of the paddle. And again, I could put that in a small buffer on that. So instead of it being at that spot, no. If plus ball dot width, because this is going to calculate the top left corner of the ball, but this is going to give me that top right corner of the ball, or at least the right side of the ball. Yeah, I like that better. And we kind of see it does have that little bit of ghosting, where it looks like it's only coming up to here, but where the new position is going to be right there. So it's going a little ahead. So let's uncomment this. So it's still... I was going to say still renders there. Yeah, so it should... Okay. Because we don't change it until the next frame. And minus all that width. I think this is how we do it. Because if the limit itself is going to be that that X position, putting it anywhere else is going to make it fly there. Should be bouncing back. It doesn't. The collision on the player. Yeah, because this one had a buffer on it, but we're not giving it this one. So I do need to change it on this one. The ball's Y position. This ain't right. The ball's X position, so if the left of the ball is to the right of the paddle, the spot that it hits. In the Y position, miscalculating plus ball dot height, and then these are kind of the same, so we can do that too. So if the left side of the ball is less than or equal to the right side of the paddle, and Y position of the ball plus its height, so the bottom of the ball is greater than or equal to the Y position, so the top of this paddle, the bottom of the ball is equal give that a buffer of 2. So if at least the bottom 2 pixels of this one are still within the top of mine, the top of my paddle, and the top 2 pixels of ball are on the bottom of mine, it bounces back. That should be right. Just trying to line it up. Ooh, that works. That works clean. Now we still have the thing where it gets stuck in the corners. Ooh, that was weird. This should be a lot better once we get things moving in respect to delta time. Which is that? Pause screen. We're going out of order. Let's do this random. If ball.x velocity is equal to 0, we're just gonna have it re-roll. Y velocity being 0, we don't care because that just means it's gonna move horizontally, but I don't want it to move vertically. Oh, then ball.x velocity is equal to that random number. That's what I was forgetting. I have to make it equal to, I have to assign that value. Value straight from my ass. I love it when it goes slow. It goes really fast, and it just goes slow. And we'll just try... I'm just going to test the randomness of it. Yeah, that's pretty good. Let's make it a little bit... Because I'm also tempted to throw when it's hit, to also make it random when it collides. Update the x velocity. Rand if ball.x velocity is equal to 0, then ball.x velocity is equal to another reroll. The odds of that being 0 2 slim to none. It's unlikely. It's possible, but it's unlikely. We're making Pong a little bit more unpredictable. Ooh, that was weird. Why is that doing that? Did I put it in the wrong spot? Was it just missing? Or was it just, counting points. This is actually kind of fucking brutal. Damn it. It wouldn't happen. Straight up happens. So let's just undo. As if we want to up the difficulty. But, well, now starts with random direction and velocity. I closed my thing by accident. Let's do... I think this one should be a while. Thank you. That's exactly what I just made it be. Awesome. So that way it will always catch. So let's do... We now have a game over condition. We'll set it to 10. And if we pause it... So let's make the case first. Case game over. If player.score is greater than the CPU score, DPQ text print F using null 1 at 150, 100. Player wins. Else if CPU score is greater than player score. RDPQ text print F using null at 1, 150, 100. CPU wins. Then we'll do RDPQ text print F using null at 1, 150, 200. Press start to play again. If controller button dot start scene. Let's sketch up a few things. Player dot score equals 0. CPU score equals 0. Current scene equals game start. But how do we get to game over? That is when player score, we'll set it up here. If player.score is equal to, we'll say 5, then current scene equals game over. And if CPU.score is equal to 5, current scene equals game over. We have a few issues. Entity has no field score. I capitalized, I shouldn't have. Let's test that. I know I could just lose just to make sure it works on purpose. And that's what I might do. If I lose, I did it on purpose. If I win, then I was trying. That's how this is gonna work. Fuck. I said it's a 5, right? Or I said it's a 10. It's going so slow. War of attrition. What did I set it as? I said it's 5 or 10. Should be set to 5. Oh, okay. I see what I did wrong. I don't break. So it doesn't change. It needs to break from here. Because I set it to one thing, then immediately it resets it to another. That's why it doesn't end. CPU's too good. I'm just gonna lose. Okay. I should get the Y. Let's get Y200 and X150, but it's so far off. Why is that so far off? Set to 100. And we'll just rush this one. I might fix up the, what happens when you hit the ball. Size, that's too big. Size, one time. It's a little bit too random. I don't know. I just need to get this through. 4, 5. Okay, that's until I can figure out how to get it centered. That's gonna have to be. And then start. Okay. Let's set this to start scene. I think it's because the it's counting the width or something. I have no idea. So the collide, the x velocity is going to be the opposite, so it goes in the other direction. The y velocity is going to be random. But why does it then... Ooh! I just realized I just dropped a whole bunch of frames. Shit. When did that happen? Over the last 15 minutes. So this seems to be going alright. Looks like every time I make... We'll just set this to... If it's going back, it'll be +5. And if it's going this way, it'll be -5. Just so it's the same. It's feeling a little too not samey. I don't know why it's doing that. There's times it just fucking goes. See, rand. 1 or 0. Excuse me. I want this to be... If rand out of 2, that's not gonna be what I want. If rand %2 or modulo 2. X velocity is 5, else ball dot x velocity equals -5. So this is going to set up random, either 0 or 1. If it's 1, it'll set it to true, so then it goes to 5, else if it's 0, it's going to go to -5. I look up the random function again. It should be pretty constant. Yeah, this is a lot more, lot samey, but it is pretty quick. ACP wins. I made an I. Nice. And we press start. We start again. So next I want to... We have the game over screen. We press start to replay. Let's do our velocity momentum. So we'll be working with delta t. Which to do that... How do I make delta t again? I want a timer subsystem. So we need to initialize our timer. Which we already have initialized. But I just want to get ticks. So let's get tick rate. Tick read. Excuse me. So let's set up uint 32t. Last time, let's set that to bit ticks. And we'll just do it in tick. Uint 32 underscore t. Current time equals get ticks. Oh, where's my delta t functions? I had these written down. Where I have them? Give me 1 second. I need to figure out where I put these delta time formulas at. Put my delta time. Actually, we can set these to 0 for the moment. Just to initialize them. Then we need to set it here. Current time. That's going to be set to get ticks delta uint 2t delta time equals set to 0. Delta time equals current time minus last time. Last time equals current time. Yes, okay. So now we can calculate our delta time. I think we're going to need... I don't think we need to lerp anything. I'm not setting any limits. But I think what we need to do is every time there is a velocity being used, we're going to have to multiply by that delta time. Nope, I want it. That's not going to give me an issue. uint32 to int. Let's just try adjusting the player's velocity using delta time and see if that makes a difference. Or we'll see how much of a difference that makes. See if it's a little bit more consistent. Because if it breaks it, then I don't want to do it for everything. Let's load. Oh yeah, there's no fucking difference. So we need to do... I need to do delta time. Let's try dividing that by 100. If we have to, we'll do 1,000. We're still inconsistent on our bit rates. No, we seem to have cleared up. So let us reload again. Nope. Let's do it by 1,000. It's ticks, so it could be an extremely high number. I may need to adjust that ticks millisecond. F. 10,000? If I need to, I'll print delta time. Just to kind of see what it is. Let's print delta time. Let's print F. No. Using 1. Let's say 20% LD. Delta time. It's not even showing me. Oops, make clean. Make, just to refresh everything. Get ticks. Millisecond or microsecond? Is that what the options are? Microsecond or millisecond? I don't think we need microsecond. Let's try get MS. We'll do 1,000. Thankfully on this one, it's just printing out immediately so we can see how bad it is. I don't move. 5 by 10? We'll just see what the delta time actually is, instead of just guessing. We may even need to readjust the amount of velocity that we have. It's about 16, 17. It's still pretty quick though. So we're multiplying that by 5. Let's move it by 1 then. And we can do this similar thing for the Y velocity. And sketch these. Grab that. This is for, hopefully if I do this, things move a bit smoother. It's still pretty quick though. Why does it launch sometimes? move at a 10th that speed. Then let's not divide this by a 10. Let's divide delta t by 2. We may have to change from millisecond to microsecond to get a little bit more kind of preciseness to it. Oh, this is so much smoother. For some reason, it just wants to go. Okay, so every time we have to call... How do you do this? Every time we're using the velocity to move? Or every time we update our position. That's what we're gonna call delta t. Oops, I already have that. Oh, I missed one value. That's why it just kept launching. Let's try this again. Ooh, this is quick. That's real quick. Then we need to do... Let's do microsecond, and we'll divide by 2,000. And let's print our delta time again. Just so we have an eye on the value. Let's do 2,500. I need to quit closing this thing. I can just reload it instead of having to redrag in my... It's close to what it was before, but it's still really fast. Let's do... We're just finding the right value. 3,000. Make it. Let's back up. Oops, to unload. It looks like it feels like it broke my collision detection. Kind of jittery still. Let's do... Check my... layers. Let's get ticks, but not in a time. Let's see how big it is. Gonna be a big old number. About 73,000. Let's just divide that by 10,000. And I can't lower my velocities anymore. They're 1. That's 78. Jesus Christ. Still real fast. Oh. And it gets real... It's a good speed, but then we have some flickering. Let's change up. Go from filters, resample, filters. Resample, anti-alias to de-deader. See if that changes the way it looks. Or how much it does. Setting size 1 times. Pixel perfect. Settings size 1. This could just be that drawing primitive graphics isn't usually the smartest idea. But you know, we get what we want to a point. Video. No, overscan. Let's try pixel accurate. I think we're gonna super sample. Let's try. I don't know why there's green dots at the bottom. I don't know if you guys could see that. But there's just something about the graphics library that's kind of fucked up. That is what I wanted, so that works. It's pretty smooth. It's better. I think having it a bit too high is what's gonna really fuck it up. Okay, last hour. Let's try to do... I'm not gonna lerp it. We did what we could. This is fine. It gives it that classic Pong. Let's try to do this set score screen. So let's go into, we'll call this mode set. And instead of starting at start screen, we'll be starting at, no. Stop. Hush, hush. Cat's yelling at me. Let's do it as... Ooh, okay. RDPQ, text, printf, null 1, at x 100 200, press B to change modes. You know what? We don't really even need to have it as a separate mode or scene. Yeah, we'll do C up and C down to change points. No, change. What's the word I'm looking for? Change goals? We're going to have... We'll set it up here. Int needed score. Ooh, to change target. RDPQ, text, printf, null, 100, 250, is that 150? Yeah, that's 140, 150. % D, and needed score. If controller button dot C up, add 1 to needed score. If controller button dot C down, plus minus needed score. We'll actually change this here in a second to if needed score is greater than, say, a limit of 100. Then needed score equals 100. If needed score instead 1, I have this the wrong direction. The alligator's hungry for this one because that one's more. It's less than 1, then needed score plus 1. So that way we can't, it'll reduce to 0, but then if it's below 0, it's gonna go to 1. And if it's above 100, it's gonna go to back to 100. And then down here, where we calculate, or we determine if someone's won, needed score, and needed score. Go up to line 109. I wish I could press a button, it just takes me there. Line 109. One finger was faster than the other. Into needed score, we start with 5. Forgot to initialize it. Always initialize your variables. Okay, that's too much. This needs to be, let's try 50. Change target. $25, 20, 25, 50, 150, 200. Ooh. Oh, that works. Okay, let's try it. Let's do 2. I need to hide the delta T. Excuse me. Ah. That's doing so good. I wonder if I need to have the ball's velocity be a little bit higher than the paddles. I mean, don't get me wrong, but this computer's kicking my ass. I'm just gonna have to lose it. I just want to test to make sure this works. Okay, and then set it to 4. or to 3, whatever I had it as. Okay, cool. Let's say about 100. Put that at 30. I need to hide all the time. Excuse me. Let's put this at display width 5x2. I think it's gonna make it appear just a little bit off-centered, but no. Yeah, just slightly. Oh, let's CP1. Ooh. Yeah, we have that. We could change difficulty by speed, and we set it to, if you use left or right scene, then it changes speed. We're already at 3, I don't know if we want to divide or multiply, because we're using ints, so that makes it a little bit tougher to do. So really the last thing to do, I expected this to take 2 days, at least, is to change the ball's color every time it's hit. So let's do DPQ set load bill, and I want to use what data type is that? Color T. All color equals RGBA 32. Let's do OXFF, OXFF, OXFFO. Still using ball color. I hope this works. Actually, let's do... because only this is going to affect that, and this is going to reset the color. I need this rand function again. And then on ball collision, ball color equals RGBA 32. Actually, what is the individual? Uint 8Ts. Uint 8T new R equals random. and percent 256 uint 8t new g equals random 256 u int 8t u int 8t new b equals random 256 ball color equals RGBA new R new G new B XO. Need color underscore T new ball color equals new R new G new B ball color equals RGBA new ball color. Nope. Okay. How's it want this? How's it gonna do this? Excuse me. Oh, these are structs. I do it as expect an expression. No, I should be able to do it as... Didn't realize that these were the same type. Where is the declaration for this? So this is accepting the color. HBA 2. Oops. Okay. I don't think that's right. Into 23. RGBA 32. Come on. OXLO. Ooh! Okay. So then, just need to copy this. Save. Make. It works! It's a lot of blue, it's a lot of pink, and there's some green. There we go. Now we're not in like pure values. If it goes to black, that's gonna be real tough. Or like a gray. This is so dumb. Ooh, that's a dark value. Ooh, you can't see it. Okay, so this is what I wanted. We have Pong. Not the best Pong. Runs kind of weird. But it is... Actually, you know what? I wonder if I'm not passing... I'm just gonna show off a lot of these. We want to use these later, we'll use these layers, but right now I'm not using them. Should I GPU sync? And synchronize, I guess? Let's try doing that as well. Bucket HD. No, it's still a little blurry. Just the ball, though. So if you could see it, it looks like you could, the front of it's dark. The part where that's not going to be multiple frames are writing over, it makes it look dark. No, I don't need those. I'm sure I just kind of did as well as we could. NTSC. NTSC adaptive? No. That's kind of a shame that I don't know. Maybe I'm just not, don't care about that. Yeah, we don't have expansion. Not using any of that. Oh! I wonder if my yeah. Let's try reloading it from that. It's very motion blurry. It's not... This is better, but it's not perfect. I think I'm just gonna have to, nearest neighbor. That's a bit better. Let's just try none. I wonder if shader's kind of messing with it. This looks a bit better. But it could just be, Could just be the system. Again, this is a Nintendo 64 we're emulating, so not like we're running on the best hardware. There is... I'm lost in my own code. Up here, let's do... filters disabled. We're kind of just in the point. I am about to end here in a little bit. This has been a ton of fun. I am so fucking happy we got this far. Like, we did it. I didn't expect to do it today, but we did do it. No discernible difference, really. That could just be a 64. I probably don't have the right settings on, or, you know, for whatever reason. The paddles move great. The ball itself, though, doesn't. So I wonder if... They're all being drawn and erased at the same time. Oh, I could not see... I can't see the ball. Oh my god. I was like, ball disappeared. That's a weird glitch I gotta figure out. Nope. Yeah, see, if you notice that, like, it looks like it has a bright side and a darkened side, like it's a shaded ball, but it's not. It kind of appears more rounded. I don't know how that is on your guys' end. But, you know, I'll say it, that's Pong. We'll try one last thing. I had a funny idea. I think we can probably get to it real fast. The logic shouldn't be that bad on it. More or less the same. Okay. That was cool. I am so happy we did that. Now time for a little bonus project. This one should be quick because it's just gonna be a gag. Crunch. What do we have here? Pull up other one Pong. We'll get this one closed, but I want some information off it, like my make file, and then bitrate.c. Copy, paste. Bitrate.c4. Oh, bitrate. Because what we're making is the Bitrate Destroyer. I have a funny idea. Bitrates. So first we're going to need to include dragon.h. Yeah, you can get that configuration for me. Thank you, appreciate it. It's main. So let's display or let's initialize our display. Resolution 240, depth 32 bits per pixel. Let's do gamma none, and filters resample. Hush. uint 32t for display width, which we will set to display get width uint 32t, display height, we'll set to display get height. Why are you not doing their thing? And all we need is RTPQ init. Got a funny idea. Wow. 1. Surface. Nope. Surface type. Display. We'll call this while not display equals display. Try get. DPQ attach clear. This null. DPQ set mode fill. I hope this works. RGBA 32. OXO, 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 0. Our DPQ fill rectangle 0, 0. Display width, display height. This guy's gonna be so fucking stupid. I need current color equal to RGBA 32. OXO, 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 OXO. Just set it for black. Let's say color T. Or int I equals 0. Plus I. No. I is less than display width increase I for int j equals 0. J is less than display height. I think that's going the wrong way. Height, width, increment j, uint 8t, just expecting we get a bunch of these. New r equals random 256. New G equals random out of 256. Uint 8 new B equals a random number 256. Current color equals RGBA. New R G. New B, that means 32. OXOL. RDPQ. Set. Mode. Fill. Current color. RDPQ, fill, fill, rectangle, I, right? No. J, I, J, I. So the idea is that for every time it's going to go through, it's going to give a random color to every pixel, and I hope it destroys the frame rate. Terminal, problem, do few arguments of function, call, which one? Line 4? Oh, which one is my frame buffer count? It's the third value. Let's set that to 2. Visualization long void. uint32_t. Oh, I need, these are functions. Oh no. Oh no. Explorer.exe here. Pause procedure warning. Oh, nope, because I forgot to draw it to the screen. DPQ, detach, show. Show me the Bitrate Destroyer. I don't think it works. I think this is too much for it to handle. Damn. Maybe that's, the rectangle's small. Ooh, where'd I put that? The Bitrate Destroyer. She works. But not quickly. That runs like shit. Fucking bitrate skyrocketed to 6,500 on my recording. Oh my god, it tripled. That's so awesome. Oh, I should hand that one out. That's the Bitrate Destroyer. That's awesome. Alright, so we are just gonna end the recording here. I'm gonna end the stream here in a little bit. Thank you guys for being here. Thank you so much for being here today. This was a ton of fun. I'm really glad we got, some sort of Pong working. It's not perfect, but you know what? It's Pong, it works, and the ball changes color. So that's all I can ask for. You know, I did what I wanted to, and we got it done. So the next step is to figure out what we're doing tomorrow. I don't know. We'll have to figure that out. Maybe we'll make a different kind of game, or maybe we'll work on making something in Blender, trying to get that to work, and then importing it and making it spin. If we get the default cube in and spin it, you know, let's try that. Let's try working with 3D objects. Just because we did get what we wanted to do done today. This is going to be great. I'm going to have to research how to do that tonight. And hopefully I can figure it out and get everything for Blender ready. I'm excited. This is going to be great. I'm so happy we made those. If anyone wants the Bitrate Destroyer, I could put that on a GitHub and hand that out. But thank you so much, YouTube, for being here. I do appreciate you. If you guys like me working on the N64, let me know, and we'll keep working on the N64. That is the plan for a while, but, you know, we'll change this if, you know, if needed. YouTube, thank you guys for being here. I love you. Do have a great rest of your night, and I shall see you when I see you. Nighty-night.